If I draw an analogy with research being like trying to beat a path through the jungle, and what we're trying to do is to make the path bigger so we can get to the truth more easily. And then along comes some guru who says, no, the true path is over there somewhere. Now, in that circumstance, what do? You've got this huge undergrowth all around. You can see nothing. You just have the word of the guru to follow. It's a judgment that you have to make. If the guru is right, and you follow through the jungle and find this huge highway, then it's the Nobel Prize in Revolutionary Discoveries. On the other hand, if the guru is wrong, then you're as good as dead, maybe literally in that particular example.
At the heart of the problem lies the issue of measurement, getting the figures right. Dr. Hal Puthoff has taken the greatest risk in trying to establish a dialogue with the inventors. His institute, in Austin, Texas, occupies an uneasy no-man's land between the scientific community, which is largely scornful, and the inventors, who are deeply suspicious.
There is a tension between scientific knowledge on the one hand and those who are understandably reluctant to tell all their secrets. On the other hand, until we actually get a device in our own laboratory and make careful measurements, there's no way of evaluating in the dark as to whether they're actually working. Now, in this case, this setup is so precise and so accurate that even if a device generates energy that would raise the temperature in here by only 1,000th of a degree, we could still determine that and therefore get an estimate of exactly how much energy was being created. Now, to reach this kind of accuracy, it took us months of putting this equipment together, writing special computer programs to keep track of all this stuff. This is a very unique, one-of-a-kind workstation for us to carry out these kind of experiments. So this entire facility puts us in a position where if someone has a device that indeed does work, we will know it.
Given the huge increase in activity in this field, what are the odds of finding a device that does tap zero-point energy?
In this field, there's good news and bad news, and we find ourselves in kind of a paradoxical position. On the one hand, there's good theoretical reason to believe that it is possible to extract zero-point energy. In fact, there's actual laboratory evidence at the microscopic level. The bad news is that so far, the devices that at least we've had a chance to examine, have not demonstrated an engineering principle by which this can be done in some effective way.
Well, there are people who are inventing and trying to develop new ways of producing energy with greater or less success. And some of these may well turn out to be interesting devices that one day you can buy and use. As an engineering or marketing and development project, that's fine as far as I'm concerned. But it doesn't have anything to do with the scientific interest as to whether or not these devices are producing more energy than you put in. On that, I'm prepared to bet my mortgage that they're not.
Our expectation is that probably within 2 or 3 years, we'll see a demonstration of the device, a robust demonstration, which shows that there is some excess energy being generated by a process that's like extraction of zero-point energy.
Whether zero-point energy or something else is the explanation, major revolutions seem to have a habit of arising from the most unexpected quarters. Carl Benz invented the car in his garden shed. The Wright brothers were bicycle makers from Ohio. They transformed the 20th century. Is it possible that one of these men could do something similar? Not only transform our way of life, but split the world of physics wide open.
I think we're at a similar cusp point today as has occurred a number of times in physics, where you have a certain period in which things kind of come together and you think you've got the answers. And then there's just a little crack here and there, but you don't think it's going to bother you. But then pretty soon you realize there's a whole new thing here we've got to deal with. And once again, people are suddenly going off in new directions. String theory, zero-point energy theory. I think we're at a cusp point again, where the physics that develop out of the next 20 years is going to be very revolutionary. And it's difficult to say what to expect. But on the other hand, it makes it a very exciting time in physics.
Revolutions, of course, take many decades to be established. But those who believe that we are on the cusp of a major revolution, both in energy production and in scientific thinking, are already considering some of the key implications, both positive and negative.
There's an interesting philosophical question, is that when we had bows and arrows, the impact we could do on the rest of the world was rather limited. With nuclear energy, we have a source of energy that can destroy us. Zero-point energy could annihilate us. I think it's increasingly dependent that we understand how to control ourselves and the energy. If we don't, it's too late.
If these new and limitless energy sources are for real, this is going to change every aspect of human life. It will be the end of the fossil fuel age. No more pollution, no more smog, no more oil spills, because we won't be shipping millions of tons of oil around the world. In fact, it's hard to see any disadvantage. But I can think of one. If we have unlimited amounts of free energy, where is that going to go? Energy always degrades eventually into heat. So if we all have thousands of kilowatts to play with, the Earth may heat up and eventually become as hot as